Hello and welcome to today's video. We're going to do some practice with truth tables. So in the last video we kind of talked about what truth tables were. We went through the process of doing them with our connectives, and we're not going to quite do the proofs yet with them, but we're going to do practice with some more advanced ones because this is what you're actually going to see in the class. So remember, quick overview, truth tables are used to show all possible combinations of statements and connectives along with their truth values. So you start on the left hand side and you kind of put everything that are components. You kind of have to work your way up to the actual statement, and then eventually you kind of look at the truth values of the actual statement based on the values of those other two or three or four propositions. So you kind of start with the basic propositions and work your way out. And we'll talk about how we do that with these more advanced ones here. Because now these are the ones that we haven't really seen. We've only seen those basic ones, but how do we start with something like this? So it says not P implies not P and Q. So I see that we kind of have two parts. We have P and Q, and like I said, we want to start small with the most basic pieces, and then we get bigger and bigger. And again, this has two propositions, so I'm gonna have P and Q, and then I see not P, right, because that comes up right there. And then I see, so you kind of want to go just list by list, list all the propositions that you have, and then you kind of work your way through there. Then one I see next is I see P and Q. And then lastly, I would see not P and Q. So we kind of have to break it into as many small parts as we can and end up with our final statement. And then lastly, I guess we could obviously do the implication. So we'd have to say that the not P implies not P and Q. Okay. So now let's do the truth table. So as usual, we start off with all possible conditions. So we have P is true twice and P is false twice because we have to consider all possible scenarios with the two variables. So with P could be true and Q could be false, and P could be true and Q could be true, and so on and so forth. Okay, and then we just work our way down, and you'll see why we need to have each part listed out. So now let's start with not P. So not P obviously is going to just have opposite truth value as P. So it's going to be false, false, true, true. Then now P and Q. Okay, so P and Q, if you remember from our last video, we said that this implies an inclusive OR. So if both are true, this is also true. So P and Q is true. And well, actually, this is P and Q. I meant P or Q, my bad. So P and Q is obviously only going to be true when both are true. So the rest is all false. So false, false, false. Okay, then now we have not P and Q. Well, this is going to be the opposite truth values of what we just had over there. So it's going to be false, true, 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 because the negation just literally switches all the truth values that you had. So now the last one, the implication. So now this question is, does not P imply not P and Q? So you really have to remember what we did, what the situation is with this connective, this implication here. So the only time that an implication is going to be false is if not P is true and this one is false, because that says that not P does not imply that the other one is true, because not P is true but the other one is not. So be careful with that. So the only time this won't be true is this will be false is if not P is true and not P and Q is false. So let's look at the list. So first I'm going to look at not P, and that's false in this case. And then I see not P and Q is false as well. So does not P imply that not P and Q? I don't have any evidence to say it doesn't, so that's true. Alright, so not P again. Well, not P is false, so no matter what the truth value of that's going to be, I'm not going to have evidence. Because like I said, the only way this is going to be proven false is if not P is true and then not P and Q is false. So let's look at the next situation. We have not P is true. Then we have not P and Q is true as well. So that's going to be true. And then I have not P is true. And then not P and Q is also true. So that makes this statement true. So what I want you to notice is that all four statements are true. What do we call that? We call this a tautology. Tautology. And we talked about that in the vocab section of one of our early videos on logic. So tautology is where all situations are true. And let's look at the statement again and figure out why can you kind of predict that that's going to be true? So, does not P imply not P and Q? Think about that. So if basically not P, that implies that P is obviously false. Does that imply that not P and Q? So for P and Q, I know the only situation where that's going to be true is if P and Q are both true, but I'm not P and Q. So that means that one of those two aren't true, and if not P is true, then that implies that the rest is not going to be true. So you can kind of use logic to reason why that's going to be the case, and you could see that that's not going to be true. So, well, that's going to be true all the time. There's not going to be evidence against it there. So that's a tautology there. All right, so let's look at the next one. So draw the truth table for P or Q with the exclusive or implies not P and not Q. Okay, let's see what we have here. So again, we've got two building blocks. We've got the P, we've got the Q. What else do we have here? We have P and, well, we have not Q. That's the simplest part. So we kind of want to go, again, from simplest to most difficult. So then I'm going to do the exclusive or. So P and or Q, exclusive. Then we have P and not Q. Then lastly, we have not P and not Q. I guess I said not too quickly because now I have one more, which is P exclusive or Q implies not P and not Q. Let me make sure this is on the screen. Let me move this over a little bit. Hopefully you guys can see that now. Okay, so now again we start here. We start on the left hand side and we just work our way across the truth table. So first one, P and Q. Remember, we have the four building blocks: true, true, false, false. And then we go true, false, true, false. Okay, so not Q. Well, if Q is true, not Q is false. If Q is false, not Q is true. And so just, again, as always, negation has the opposite truth value. So now we got to be careful here with this one. Remember, this is the exclusive or. So that means that you can have one or the other, but you can't have both. Exclusive or. Okay, so one or the other, but not both. So if P and Q are true, this one's going to be false because you can't have both. But if one of them are true, it's going to be true. Both false, false. All right, so P and not Q. So we're looking at the P column and the not Q column and trying to find if they're both true. And in this case, it's not. In the second case, it is true. In the third case, it's not true. And in the last case, it's not true either. So we only have one situation where we have P and not Q. But now we're doing the negation of that, so we're saying not P and not Q. Well, that's going to be true every time that the other one was false. So now we have three of them that are true and one that's false. Again, because when we do negation, all we do is we take the opposite truth value of what we had before. Then lastly, with the implication. So kind of the hard part. Now, does P, the exclusive or Q, imply that not P and not Q? So I think I made not, the parentheses a little off. So not parenthesis P and not Q. Okay, that looks better. All right. So again, we need to be dealing with this column right here and this one right here, right? Because those are our implications. And remember, the only time this can't be true, the only time we have evidence to say false for this is if this is true and this is false. Because that means that the P and Q, this part, does not imply the other one, because this happened, the left hand side happened and the right hand side didn't. So that means it does not imply it. It does not lead us to know that the other one is true. So that's what we're looking for. All right, so the first one, the P exclusive or Q is false, so we know this is going to be true. We're not going to have evidence to say otherwise. All right, next one we have true. So this exclusive or is true, so P exclusive or Q. And then now we have the other one is false, so not P and not Q is false. So that means we have evidence to say that this is not true. The last one, the third one, we have true, true. That looks good. Next one we have false, true, and that one's also going to be true. Be careful with why that last one is true. That's because the P exclusive or Q, just that being true, that being false, does not mean that the other one's not going to happen. It does not mean that not P and not Q is not going to happen. It just means, this implication right here, this rule, just says that if P and Q happens, P or Q happens, then not P and not Q will happen as well. So we didn't have any evidence to say that didn't happen because P or Q never happened. So no evidence there. So that's our truth table. That's our final table there. So hopefully that makes sense. Hopefully you get these conditionals a little bit better now. And then next video we'll actually do some finally do some proofs with the truth tables. So thanks for watching, and let me know if you have any questions. Have a good one.